When we talk about probability, there are two types of probability, two different ways of looking at it. One of those ways is theoretical, which is based just on the possibilities, what could happen. And the other one is empirical, which is what did happen. We're going to actually do something, actually do an experiment, and look at what the outcomes were. So I'm going to look at comparing the two. I like to do this with students in a class using M&Ms because they think it's fun. If there's food allergies or food regulations, of course you can't do that. But anything that's um, different colored or different, not shape so much or size, but different colors works really well. I happen to have the fun size pack of paper clips right here, colorful paper clips. You can use dried beans, anything that's convenient and not too expensive. First, we want to look at the theoretical probabilities. So the big question we're trying to answer is, if I pick a paper clip out of the bunch without looking, what's the probability that I get a given color? First, we got to know what's in this pile of paper clips. For that, we can use a frequency table. We talked about this with data and statistics, but it's certainly going to be useful here. So I'm going to list my colors, and I'm going to count. And then we'll look at how to find the theoretical probability of each color. Well, let's see. I got some white ones, looks like 5. I got some pink ones, 4 of them. Three blue ones. That one really likes the red one. 6 red ones. Makes no difference whatsoever what order you list them in. And 1 purple one that's trying to pretend it already got counted, and another purple one, so 2 purple ones. For a total of, I'm just gonna move those out of the way. Altogether in my pile, I have 20 paper clips. The probability, if I pick one out, of getting a certain color, we find theoretical probability by looking at, for a certain color, how many are there of that color out of how many there are total. Well, the total is 20 all the time. So probability of whites is 5 white ones out of 20 total, which is 25%, 0.25, 1/4, whatever way you want that to be expressed. You can work fractions in here by talking about reducing. You can work percentages in here. Pink ones, there's 4 out of 20, which is 20%. Blue, 3. Red, 6 out of 20, which is 30%. And purple, 10%. Use quick check. You can add all those up and make sure you get 100%. Make sure you haven't left anybody out. You may be saying to yourself, well, isn't just the percentage of each color out of the total? And the answer to that question is, yeah, that's exactly what it is. That's how we find the theoretical probability. If they're 20% pink in the pile, then the probability of picking a pink one I would expect to be 20% in a perfect world. If there are 10% purple ones in the pile, then I would expect the probability of picking a purple one, I would expect that to happen about 10% of the time. So these are theoretical probabilities. On the other hand, empirical, or sometimes you hear this called experimental probability, is based on the results of actually doing something, actually doing an experiment. So I got my 20 paper clips here. If I want to know what's the probability, if I pick one, I get a pink one, I have to actually do that a bunch of times. So I'm not looking, I'm just going to pick one, and this time I got a red one. So I got my colors listed here. I'm going to make some tally marks probably. You can have kids do this in small groups, have jobs like the recorder and the picker and the shuffler, and let them trade jobs so everybody gets to do everything. Scoot these over. And we'll just count up how many times we got each color. I actually did this. I did it 50 times. We'll make a column for frequency, the number of times I picked each color. So let's see, white ones I got 17 times, pink 14, blue there were 5, red 11, and purple 3. Quick check, if I add up this column, 20 plus 25, okay. If I add up this column, I should get the total number of trials, total number of times I did the experiment. I did it 50 times, they add up to 50, we're good. The empirical probability is, again, really it's just a percentage. The probability of getting a certain color, I'm going to look at how many times did I pick that color out of how many times did I do the experiment altogether. So it's really what percentage of the time did I get that color. For white, I picked white 17 times out of 50 trials of the experiment, which is 34% of the time. Pink, 14 out of 50 is 28%. 5 out of 50 is 10% for blue. 11 out of 50 is 22% for red. And finally, purple is 6. And again, you can check and make sure those are right by adding up the column. 12 and 8 is 20. 2 plus 3 is 5, 6, 7, 8, 9, 10. That's 100. That's good. So I counted them all. Then we can compare. I got white 34% of the time was my empirical probability, compared with the theoretical probability back here of 25%. This is what makes it probability. It's not certainty. It's no surprise that those two numbers would come out different. A next step that you can take is to then combine the data from all the groups. We're going to add up all the white ones from all the groups, all the pink ones from all the groups, and so on. And we're going to look at what percentage of the time for all the groups did we get each color, and compare those with the theoretical probabilities. The expectation would be that they would be closer if we use the data from the entire group than the data just from a small group. Another way of doing that is to say, okay, do another 50 trials and see what happens. And because of the law of large numbers that says the more trials you do, the closer you get to the true probability. So the bigger our sample size, the closer we are to making an estimate, the true estimate for the population. we would expect that as we pull in more and more data, these empirical probability numbers would get closer and closer to the theoretical ones that we calculated earlier.